Okay, let's see. So we were looking at the solutions of how to solve quadratic in radical equation. How to solve radical equations. So we can look at one example, one how we can review one of the examples. So how we can solve, let's say the square root of -4u minus 3 equals to minus u equals to minus u. So here, since we say since we are looking for the value of u, we are looking for the value of u there. Then we look for the value of u, which can make this one to be what? Positive, right? That can make it to be positive. So here, this is actually similar to minus 4u minus 3 raised to what? 1/2 equals to minus 2. Then, since we want to remove this radical here, so we multiply everywhere by square. So what you do in one side, on the other side. Again, you should remember that you are applying the square on all of it, not only one, on all that negative u. So this is equals to minus 4u minus 3 equals to what? So when you apply the square in all of this one, then it is equals to u squared. Equals to u squared.
So why is it positive?
Sorry, what's that?
Why is it a positive u squared?
So it is because u minus u multiplied by minus u, what you get. So minus u and then u square. This is equal to minus u multiplied by minus u, right? And this is equal to when minus times a minus multiplied by minus is equal to what? So, and finally, this is equal to what? U squared. It's equals to u squared. Now, after this, now we take all these values to the other side. So then it will be u squared. When you take the u to the other side, you get plus 4u. When you take minus 3 to the other side, plus 3 equals to what? Equals to 0. So since this is not a perfect square, then we use the what? Let's see. Let's see. So the product is equals to 3, and the sum is equals to 4. What are the two numbers? Yeah. So u squared plus 3u plus u plus 3 equals to 0. Then we now group them. So u plus 3 plus 1, u plus 3 equals to 0. Using the 0 product before that, then we factor out u plus 3, u plus 1 equals to 0. Using the 0 product property, that u equals to minus 3 or u equals to minus 1. Equals to minus 1. Now, now since you want to check whether the minus 4u minus 3 equals to minus u. Yeah. Now, since this one is the square root, then you don't have to check it, right? Because what we get here, the u's are what? The u's are negatives, right? So when you bring the negatives here to this u there, then it will make this one to be what? Positive. So therefore, the two of them are the solutions of what? Of this equation. So it means u equals to -3 and -1 equals to -3. So you don't actually have to waste your time checking it. As long as all these are negative. So if you take this one here, then it becomes what? Positive. You take this one here. Any question? Okay. If there is no question, now let's come to the complex part of this one, which is section 8.8. 8.8. Section 8. This one is actually complex. Complex. Now, the square roots of a -1, the square root of a negative number, the square root of a negative number is equals to I. And this I is the complex number. The I is the complex number. So the square root of I is a complex number. The square root, let's say the square root of -3 is the same as distributing the squares in which one of them, which is the same as the square root of -1 multiplied by 3, which is similar to the square root of -1 multiplied by the square root of 3, which is the same as what? I, the square root of the square root of 3. Since the square root of -1 is what? Is I. The square root of -1 is I. The square root of -4 is equals to the square root of -1 multiplied by 4, which is similar to the square root of -1 multiplied by the square root of 4, which is equals to the square root of -1 is I, and the square root of 4 is what? So we usually write this one as 2I. So you take I to the other side. Are we together? So this I there is the complex number. The complex number. Now, the addition and the multiplication of the complex numbers are similar to what we did on the roots, okay? So, like for example, if we have this 3, okay, before we go to this, A plus BI is also a complex number. So this is also a complex number. Is the complex. Where A and B are real numbers. are real numbers. And A is the real parts, and B is the complex. A is the real parts, and B is the complex parts. Now, 2 plus 3A, sorry, 2 plus 3I plus 3 plus 4I, yeah. To solve this one, to solve that, then what you do is you add the complex and the real parts. So you add the complex and the real parts. So in this case, this is similar to 2 plus 3I plus 3 plus 4I, which is equals to 2 plus 3 plus 3I plus 4I, which is the same as 5 plus 1 plus 7. So we add the complex and the real parts, so you don't mix. So just the same as the roots. So you add the ones which have same roots. So in this case also, for the complex, you add the ones with the same complex numbers. Same complex numbers. Any question? Now, when we multiply, multiplication is also the same. So multiplication is also the same. 3I multiplied by 4I. Yeah. So we say the square root of -1 is the same as I. The square root of -1 is the same as I. Now, what is -1? So this is similar to -1 raised to what? 1/2, which is equals to what? I. Which is equals to I. So therefore, I square is equals to what? -1. I square is equals to -1. Since you can multiply both sides by what? The square here. So you get I square to be equals to -1. Therefore, when you multiply 3I multiplied by 4I, then it is the same as 12 multiply I by what? By I, which is equals to -1. So since I multiplied by I is the same as I square, which is equals to -1. It's equals to -1. So when you multiply I by I, you get -1. Now, 3 plus 4I multiply 2 minus I. If we want to multiply the two of them there, just the same as A plus B multiplied by C plus D is similar. It's just similar. So in this case, you can say A, C plus D plus B, C plus what? So it is similar thing. Yes. So in this case, you can say you distribute here, this is like 3, 2 minus I plus 4I, 2 minus I. That's 4I, 2 minus I. Just like this, just like A plus B multiplied by C. So you can use this to distribute here, or you can use this one. So A multiplied by this plus B, this plus B multiplied by this one. So when you open the brackets, then it will be A by this plus A by D plus B this plus this one. So here, that's the same thing, 3 by 2. So 3 multiplied by 2 minus 3 multiplied by I, 3 multiplied by I, plus 4I multiplied by 2 minus 4I multiplied by I. 4I multiplied by I. So when you simplify, you get 6 minus 3I plus, this will give us what? 8I. Okay. So 4 by 2 is what? Is 8I. Minus 4I by I is what? -1. Multiply by -1. Finally, this is equals to 6 minus 3I and 8I is what? That's 5. Minus this will give us what? Plus 4. Right? Plus 4. And finally, this one is equals to 10 plus what? 5. Are we together? So as long as you know, let me write them here so that we don't forget. I multiplied by I is equals to what? The square root of -1 is equals to I. So when if this is similar to -1, raised to 1/2 equals to what? I. If you remove this exponent here, then you multiply both sides by square, which is -1 equals I square, which is the same as I multiplied by what? I. I multiplied by I is what? Okay. Any question? Any question? Now, that is the simplest part of complex. So we don't have to do a lot of, because this is actually the introduction. There is a course by itself called complex analysis. Complex analysis. So if you will do mathematics in future, you might do complex analysis. Okay. Any question after that? So that is section 8.8. So you can still go and check some of the materials in your textbook. In your textbook. Okay, now let's come to the next section, which is section 9.1. Section 9. We are almost done. We are almost done with our course. We only have 9.1 and then we only have chapter 9 and then go to chapter 11. Hey, 9.1. This section we are going to solve the quadratic. This chapter is more of the quadratic equations. The quadratic equations. Now, in section 9.1, we are going to use the square root property to solve the quadratic equation. To solve the quadratic equation. Now, if we recall the square roots property, the square root property, the square root property. Now, if we have, let's say, x squared to be equals to 9. X squared to be equals to 9. Let's say have x squared to be equals to 9. Then this is the same as x squared, and then we bring 9 to the other side. Is equals to what? Right? Right? So it is the same as x squared. We bring this 9 to this side. Is equals to what? Is equals to 0. Then x squared minus 9 is what? What is x squared minus 9? It is a difference of 2 squares, right? So this is equals to x minus 3, x what? X plus 3 equals to what? Equals to 0. Now, using the zero product property, then our x is equals to 3 or minus what? Minus 3. Our x is equals to 3 or minus 3. X equals. Then, therefore, now, since we have seen that our x equals to 3 or minus 3, then x squared equals to 9. Yeah, x squared equals to 9. If we want to remove the square here, we do what? We multiply by half, right? So then our x to multiply by 1/2. What you do in this side, we do it in the other side, x raised to 1/2. X raised to 1/2. Then our x will now be equals to, now this x 9 raised to 1/2 is similar to what? The square root of what? 9. So x raised to 1/2 is similar to the square root of 9. So then our x, we said if n here is 2, if the root here is 2, then what do? You take the what? The absolute value of, right? So using what we did in the last section, we say if this n, and this is the root here, is, we say even, sorry, is even, then we take the absolute value. This absolute value is the same as positive or what? Negative. So therefore, our x is equals to plus or minus. Our x is equals to plus or minus 3. Our x is equals to plus or minus 3. Just the same way as we have that here. So then, x equals to plus or minus the square root of 9. So when we are doing, this is now what we call the square roots. The square root property, where we can say, if we have x squared to be equals to, let's say, p, x squared to be equals to p, then x equals to plus or minus the square root of x is equals to plus or minus the square root of x. And this is now our square root property. Square root property. Any question? So that x, this x squared minus 9 equals to 0 is a quadratic. So the x squared minus 9 equals to 0 is a quadratic. So this is a quadratic equation. So we did the quadratic expression. Now we are dealing with quadratic equation. Now we want to get the values of x. So if the highest power of x here is 2, then it becomes a quadratic equation. Now using the square root property, we will use the square root property to solve this quadratic equation here. Right. Now, let's come to the next example on how we can use the square root property to solve the quadratic equation. So example number 1. Use the square roots property to solve the quadratic equation. 3q squared equals to minus 3. 3q squared equals to minus 3. Three q squared equals to minus 3. How will you use the square root property? Now, here, what you do, you make sure that the root is on one side and the other values are on the other side. The one that has the root should be on one side and the other value should be on the other side. So in this case, what do? You divide both sides by what? So you divide both sides. And what you get is q squared equals to negative 3 all over what? 3, which is equals to negative. Is equals to negative 1. Which is equals to negative 1. So our q squared here is equals to what? Negative 1. Q squared is equals to negative 1. Now, using the square root property, then our q is equals to plus or minus the square root of what? Negative 1. Plus or minus the square root of negative 1. So what did we say about the square root of negative 1? This is equals to what? Plus or minus I. Plus or minus I. So then our q is equals to I or minus what? I. Q is equals to I or minus I. Are we together? Another example. Use the square root property to solve number 2. Use the square root property to solve 6c squared plus 18 equals to 0. 6c squared plus 18 equals to 0. So what you do, just like this, we check the other values to the other side. Make sure one side has the exponent. So you separate the exponent and the constant. So here, 6c squared, we take 18 to the other side, minus 1. And then you divide both sides by what? By 6. So our c squared equals to minus 18 divided by 6 is equals to minus what? 3. So we get our c squared equals to minus 3. Now, using the square root property, then our c equals plus or minus the square root of c is equal to plus or minus the square root of 3, which is equals to what? Plus or minus the square root of minus 1, the square root of, right? And this is equals to plus or minus I, the root of what? So therefore, our c is equals to I, the root of 3, or minus I, the root of what? Any question up to that? Just very easy. Is it easy or very hard? A little bit easy, right? Okay. Okay, so example number 3. So minus 3a plus 2 square equals to 64. Equals to 64. Solve that one. So we use the square root property. Since that exponent is on one side. So that means to remove this exponent using the square root property, then it means negative 3a plus 2 equals to the plus or minus the square root of what? 64. Plus or minus the square root of. So therefore, minus 3a plus 2 equals to plus or minus 8. Equals to plus or minus 8. So that means negative 3a plus 2 equals to 8, or negative 3a plus 2 equals to minus what? Minus 8. Since it is a plus or minus. Plus or minus. So therefore, to get a value of a here, minus 3a equals to 6. So our a equals to minus 2. And then minus 3a equals to what? Equals to minus 10. So our a equals to 10 over. So then our a equals to minus 2 and what? 10. Put it together. Any question after this? So make sure you remember that one over there. So 3 minus 3a plus 2 is equals to 8, or minus 3a plus 2 is equals to minus 8. Example number 4. Q plus 5 all over 4 square plus 7 equals minus 18. Minus 18. So you factor out, actually one side has the roots, you take the other values to the other side. So that means our Q plus 5 all over 4 square equals minus what? 25, right? Equals to minus 25. So you take 7 to the other side. So using the square root property, so Q plus 5 all over 4 equals to plus or minus the square root of minus 25. Plus or minus the square root of 25. So therefore, Q plus 5 all over 4 equals to plus or minus what? Plus or minus what? 5 what? 5? Since it is the square root of negative 25. Right. So therefore, Q plus 5 all over 4 equals to minus 5i, or Q plus 5 all over 4 equals to 5i. So then our Q equals to minus 5 over 4 minus 5i, or our Q equals to 5i minus 5 over. Those are our solutions. Those are our solutions. Now, since this is the real part of this one, just so you don't have to simplify part of that. Now solve d square plus 10d plus 25 equals to negative 18 equals to negative 18. Equals to negative 18. Now, we say you take the other values there. So this square plus 10d equals to negative 18 minus 1, 25. So our d square plus 10d equals to minus 1, 43, right? Minus 43. Now, if you look at that, since we have our d here and our d also here, then if you factor it out, then we see that we cannot get the values of d. So then, if you cannot get the values of d, then you can bring the d square plus 10d plus 43 to this side to be equals to 0. So if you cannot use the square root property here, then here you can use the what? The AC. The AC. So the product here is the product there is actually 43, and the sum is 10. Is there anything which can give us a product of 43 and the sum to be 10? Unless it is 43 and 1, right? So that is actually a prime number. So we cannot say 10 plus 43, we get 1 plus 43, we get 10. 1 plus 43, we get 10. So we cannot factor. We cannot factor this. So we cannot factor this. So here, so what you do here is, you can say now d square plus 10d plus 25 equals to minus 18. Yeah. So we can have like that. But here, if you look at this side here, we can actually do what? We can factorize this, right? So we can factorize this one. So the product is 25 and the sum is 10. So if you factorize this, what do you get? D square plus what? 5d plus 5d plus 25 equals to minus what? Minus 18, right? Equals to minus 18. So if we group them, so we get d plus 5 plus 5, d plus 5 equals to what? Minus 18. So what do you get? We get d plus 5, d plus 5 equals to minus. Yeah. So this d plus 5 and d plus 5 can be written as d plus 5 square equals to what? Minus 18. D plus 5 square equals to minus 18. Right? Now, from here now, we can use the square root. So d plus 5 equals to plus or minus the square root of minus what? 18. Minus the square root of minus 18. So therefore, d plus 5 equals to plus or minus the square root of actually 2 multiplied by 9, right? And then the square root of 3, right? 2 by 9 is what? 18, right? So therefore, d plus 5 equals to, this is I, plus or minus I. The square root of 9 is 3. So 3i. The square root of what? And finally, this d equals to 5 plus or minus 3i, the square root of minus. So because you take the plus 5 to the same becomes minus. How you get? So we started by looking at we saw that you cannot factorize. So you can factorize one side. And then after factorizing one side, then you can now use plus minus. So you can simplify this. This is what 2 multiplied by 9. One. This will be 5, and then
We can get a couple more people here.
the square root of 2, the square root of 9 is the square root of 3. Any question after that? Any question? Oh, still have time. Z plus 4/3 square equals to -3. How can you simplify that? Just like the other ones, you use the square root property. So Z plus 4/3 equals to plus or minus the square root of. And this is equals to plus or minus I, the root of what? I, the root of 3. Since the square root of -3 is the same as the square root of -1, the square root of 3. Then you just take, so Z plus 4/3 equals to plus or minus I, the square root of 3. So Z equals to minus 4/3 plus or minus I, the square root of. So in your exam, you can just write like that. You can just leave it like that. But in Newton, I don't think they have the plus or minus. So you can just say minus 4/3 plus I, root of 3, comma, minus 4/3 minus I, the root of 3. But in your exam, you can just write it like this.
The other side, like, breaking down the fraction.
Yes, yes. See you guys. What's up? Yeah, yeah, yeah. Yeah, you can do it.
Thank you.
All right, see you.
Oh, yeah, the second one always. Oh, really?
See you.